In this video, we'll be taking up the homework on the angle relationships in quadrilaterals. So for the first question, A, B, C, and D, we're basically using the quadrilateral sum theorem. So we're given the four interior angles, we're given three of the four interior angles, and your job is to solve for the fourth interior angle. So add up three of the interior angles plus the fourth one is equal to 360 degrees. So I basically did that for the same strategy for question 1, A, B, C, and D. As long as you're able to solve a linear equation, then these questions should be pretty straightforward. Remember to simplify and track both sides by 250 in this case, and that solves for x. Now, what you could have done alternatively, if you didn't write this, I'm just going to show for 1a, what you could have also written is just isolate x right off the bat like we did in the lesson. So instead of writing 95 plus 90 plus 65 degrees plus x is equal to 360 degrees, just write 360 minus these three angles must be equal to the fourth angle. That is basically the same relationship as this relationship here, which is derived from the quadrilateral sum theorem. So let's write that down. 95 degrees minus 90 degrees minus 65 degrees. So the benefit of writing like this is just crunch out the calculation and then you solve for x. You don't have to play with the equation, you have to rearrange and all that. Either way, whatever you're comfortable, you'll get the same answer. So I'll leave it up to you, okay? But both of these equations are derived from the same relationship, which is the quadrilateral sum theorem. The interior angles of a quadrilateral sum up to 360 degrees. For question 2, we're basically working with the same relationship, which is the exterior angle sum theorem. And I just realized for 2C and 2D, I didn't write down the theorem, so I'm just going to put an arrow here. I should have written it there as well. So exterior angle sum theorem for all four questions, 2A, B, C, and D, because in all of them, I'm given three of the four exterior angles. So I can solve for the fourth angle rather easily because the four angles sum up to 360 degrees. So like I said, in question 1, you could build this equation. X plus 33 degrees plus 116 plus 65 degrees equals 360 degrees. Or you can say x is equal to 360 minus 33 minus 116 minus 65. Either way, I'd be happy with that because in both instances, you're using the same relationship, which is exterior angle sum theorem. Okay, for question 3, it's a two-step process. You actually can't solve for 3a, you can't solve for y immediately. What you have to do is solve for x, and then you can solve for y. So solve for x, given the fact that at a vertex, the interior and exterior angles are supplementary angles. So I solve for angle x, the third interior angle, and I can solve for the fourth interior angle using the quadrilateral sum theorem. So I shortened it to QST because it's getting pretty repetitive. And I did basically the same thing for 3b. The interior and exterior angles are supplementary, so I can solve for the interior angle, and then I can solve for the last interior angle of the quadrilateral. Because if I have three of the interior angles, I can definitely solve for the fourth one. Okay, so this sheet was just a nice practice of the two theorems that we learned with respect to quadrilaterals.